What makes a good research title? A research title isn't just a pretty phrase. It's the frontliner of your study. It's the first thing read, the first thing judged, and often the reason you either stand out or get sidelined. To make it count, follow the OSMART principle: original, specific, measurable, attainable, relevant, and time-bounded. This isn't just a checklist. It's your guide to making sure your project is not only exciting, but also actually possible, scientifically sound, and competition-ready. Let's break this down. Original. Your research needs a spark. Something fresh. Something that doesn't feel like it's been collecting dust in last year's archives. Originality doesn't mean inventing alien tech. It means giving new life to an old problem, applying tech in new ways, or studying an unexplored variable. Valkyrie. Optimizing perovskite quantum dot integration in multi-junction solar cells. Boom. It's hot tech, but it has a new approach. How does the thickness of insulating materials affect heat retention? Yawn. Unless you're using something crazy like durian husks or squid skin, this topic's already been grilled, baked, and microwaved. Specific, don't be vague. Be surgical. Your title should tell us exactly what you're testing, what's being manipulated, and what you're measuring. Synthotide. Unlocking the metabolic pathways of Rhodopseudomonas palustris for waste degradation. Very clear. Organism, mechanism, goal. No guessing games. Using AI to improve agriculture. AI how? Crop health? Weather prediction? Automatic scarecrow? Define it or lose it. Measurable. If you can't test it, you can't prove it. Your project needs variables that can be measured. Numbers, percentages, visible changes. Interesting doesn't cut it unless it becomes observable and quantifiable. TiO2 intercalated MXene nanocomposite membranes for water purification. You can measure filtration efficiency, purity, cost-effectiveness, data galore. Exploring the emotional impact of music on teenagers. Unless you're strapping students to EEG machines, which you probably can't, this one's too slippery. Attainable. Here's where a lot of students get ahead of themselves. Titles that require CRISPR gene editing, transmission electron microscopy, vertebrate testing, or human clinical trials are not realistic unless you have a lab, legal permits, institutional partners, and major funding. Spoiler, most of you don't. CRISPR-based gene activation for Alzheimer's prevention. Amazing? Yes. Yes. Possible for high schoolers? Nope. Development of nitrogen-doped carbon quantum dots for corrosion resistance. Budget-friendly, testable, and sounds cool without crossing ethical or legal lines. Pro tip, you can always pivot to simulations, in silico modeling, or microscale substitutes like Drosophila, Artemia salina, or microbial testing to make the concept doable. Qualified scientists often help approve these alt methods in science fairs. Realistic is better than overreaching. Relevant, good titles solve real-world problems, especially local ones. Don't just research for research's sake. Ask, who benefits from this? Why does it matter now? Homemade electrolytes versus commercial batteries, a voltage comparison. Very relevant in disaster-prone areas and low-resource settings. Practical and empowering. Mathematical patterns in music. Interesting, yes, but unless it's tied to therapy, education, or tech, it can feel like a passion project rather than a research study. A project without boundaries is like trying to swim across the Pacific. No end in sight, no results in hand. Add a time frame, scope, or trial period to give your study structure and credibility. A 6-week study on behavioral changes of Artemia salina exposed to carbon quantum dots. Short, sweet, and clear. Developing a smart agriculture system. Forever and ever? Is it a prototype? A field test? Add those timelines. A great title balances ambition and feasibility. It's impressive without being impossible. Your goal is not to win most futuristic idea. Your goal is to do sound science that solves real problems with real tools in a realistic time frame. If it sounds like a sci-fi Netflix pitch but your lab can't even afford a Bunsen burner, it's time to revise.